welcome back. So before the break, we were looking at examples to see which trig rule we need to apply to solve a particular problem. Let's continue with that. Okay, in this diagram, we asked to find the length of BD correct to just one decimal place. So here we're working slightly differently. We're working with one decimal place, and they want us to find the length of BD. So we're going to examine our triangles, and we see what information we have. If you look at this triangle here, as it stands, we've only got one bit of information. So because we only have one bit of information, we cannot solve this triangle at the moment. Let's look at this other triangle we have here. We've got 3 bits of information, so it sounds a bit better. And we notice that we have one full pair already. So if we have one full pair, we know in this triangle, we can definitely use the sine rule. And if we did use the sine rule, we could use this full pair and this half pair. And so we could find what they are asking us to find, which is the length of BD using the sine rule. So how do we write that out? So remember, it's going to be BD over sine of the angle across it. Let's start writing that out quickly. Okay, so BD, and the angle across from BD is this angle here. So we're going to say sine of 30, and our full pair we're given is the 3 meters, and the angle across the 3 meters is 120 degrees. Right, so we're going to just rearrange this equation to get rid of the sine 30 from our left hand side, and so we end up with BD is equal to 3 times sine of 30 over sine of 120. Okay, put that into your calculator. So it's going to be 3 times sine of 30 divided by sine of 120, and our answer is 1,7320. Remember, we've asked it to find BD correct to one decimal place. So one decimal place means 1,73 becomes 1,7. So our answer for BD is 1,7. Okay, let's go to the next question. The next question now, they want us to find the length of BC. So because they want us to find the length of BC, so we've already found out that BD is, sorry, let me just grab my pen. I seem to have lost it. Okay, so BD is 1,7 meters. Okay, but now they want us to find the length of BC, so we've got to work with this triangle. Okay, now again in this triangle, we've only got 2 bits of information. We're obviously missing something else. So we've got to go back to our diagram and look to see what else are we missing. Can we find a different angle or a different side? And remember, when we were working out earlier, we looked at this triangle here. But this triangle, because we had 2 angles, we had 120 and 30, we could find this angle here, B2. And because we have parallel lines, B2 lies alternate to D1. So if we find the value for B2, we can find D1. And once we found D1, we have a lovely V pattern here. We've got a side, an angle, and a side, which will allow us to use cos rule in this triangle. So let's go and write that down. So because we know that BD is 1,7, we're going to first find B2. And B2 will be 180 degrees minus 120 degrees minus 30 degrees, which is going to give us with 30 degrees. So that's going to be the same, because B2 is 30 degrees, it means that D1 will also be 30 degrees. Okay, so B2 is 30, and they alternate, so therefore D1 also has to be 30 degrees. Okay, now we're going to try and write out the cos rule for this triangle here. So for this triangle here, because we're trying to find BC squared, remember we're going to use that side squared, 1,7 squared, plus the other side that we have, so it's going to be 1,5 squared, minus 2, and remember we've got to use this one and then that one in our bracket. So we've got 1.7, we've got to put a 1.5 in here, and the cos, the angle across BC squared, and the angle across, the angle across BC is D1, which we already realized is 30 degrees. So we're going to put in a 30 degree in here. Okay, now remember this is what BC squared is equal to. We're going to put that into our calculator. That's still not our answer because we want the value for BC. Although our answer, our calculator will give us this answer. This is obviously not the correct answer yet. We're going to take the square root of that. And so we take the square root of that, and then we end up with BC is equal to 0.9 meters. So we've answered that question because the question said find the length of BC, and we've used the cos rule to find the length of that one. Okay, so we're almost at the end of our session now. Let's quickly recap how we can decide which rule to use. Let's go. So remember, when we're deciding which rule, we've got to decide if it's right angle. If it is right angle and involves angles, then we've got to use our trig ratios. If it does not involve any angles, then we've got to use the theorem of Pythagoras. If indeed it is not right angled, then, oh, did I say something wrong? I felt like I said something wrong there. Sorry, can I just do that again? I felt like I said something wrong. Sorry, my ear was busy buzzing. My nose and my ear just got blocked. Sorry. So can I start here with which rule? Yeah. Yeah. Can I start?
3, 2, 1.
Okay, so we first check if the triangle is right angled. If it is, then we ask ourselves the question, does it involve angles? And if it does, then we use our trig ratios. If it doesn't involve angles, we've got to use the theorem of Pythagoras. Then we have the case where if it's not a right angle triangle, we come to, we've got to then ask ourselves, do we have one full pair? That means an angle and its matching side. And if it is, it means we've now have the criteria for using sine rule. So in that case, we'll use the sine rule. And remember, sine rule is used when I have angle, angle, side, or sine, side, angle. And the last but we need to know that if we don't have one full pair, then we know we can use the cos rule. And remember, for the cos rule, we need to have side, angle, side, an included angle, or we're going to have side, side, side. Okay, so that brings us to the end of this lesson where we were deciding which trig rule to use when. Okay, I hope you join me next time where we'll be looking at some of the proofs of these rules, and we will be extending them to slightly more challenging questions. Till then, bye.